Okay, I figured I'd make a video working on describing motion and looking at motion in a couple different ways, both describing it in words and then looking at it graphically, and also showing you how that could fit in to do some of the motion problems. Okay, so we're going to watch the video. This comes from Apollo 16 of jumping on the moon. So there's the astronaut. He jumps up, he comes down. Okay, so let's talk about his motion on the way up. Okay, so as the astronaut is going up, okay, what is happening? Okay, well, he's going up and the gravity on the moon is pulling him down. Okay, so while his velocity is positive and he's going up, his acceleration is going down, and therefore it is negative. Okay, he will have a negative acceleration. Standard convention is that up is positive and down is negative. So his velocity is positive as he's going up and negative as he's going down. Okay. We can also look at the very top of his jump. So when he is at his max height, that's when he changes from having a positive velocity to a negative velocity. When you have a negative, go from positive to negative, you have to go through zero. So at his max height, velocity equals 0. Okay? So on the way up, he is slowing down. Another way you could say that is his velocity. Though it's positive, it is decreasing. It's getting closer to 0. Where on the way down, he's going to speed back up. Okay? His velocity, it's still negative, but it's getting further away from 0. So his velocity is increasing as time goes on. Okay? He is speeding up as he goes back down, in this case, toward the moon. Oh. Okay? But the whole time, he still has a negative acceleration. The only difference is that here, the signs are opposite. Okay? So that means he's going to slow down. Where here, both of the signs are negative. So that means he's speeding up. Okay? This is a program that does video analysis, so I'm going to use it to track his motion, and then we can use it to analyze the graphs. Okay, first, I'm going to set the scale. I was given that this astronaut has a height of 6.02 meters with his spacesuit on and everything, so we're going to use that as our base. Okay, and then I'm going to do the analysis. I'm going to start it the second that he leaves, and I'm always going to go from the top of his spacesuit, and he's going up and up. Every time I click, it's advancing a frame so that I can get another point on the graph. Okay. There we go. And now we need to auto scale the graph so that we can see his height versus time. You can see he goes up and he's slowing down here. So you have that nice curve fit. The slope of this, oops, that was wrong. The slope of this is your velocity. The slope of a position versus time graph is velocity. So we can see his velocity starts out at 3.6. Okay, I'm looking at the slope again. It's going down, down, down. It's getting close to 0, 0.38, 0.3 to negative 0.32. That point I probably messed up a little bit on. And then it is increasing and getting more and more negative. Okay? So his velocity, or his position versus time graph, looks like that. If we had to fit it with a function, we would do a quadratic function. And it could tell us a lot more information. Okay. Now let's look at something else. I'm going to change this to his y velocity. Again, auto scale. Okay, now we have, it's not the height versus time, it is the velocity versus time. And notice this graph is linear. Okay, it constantly goes from, starts out positive, goes through 0, and then goes negative. Okay, so his velocity versus time graph is negative, and it shows the same thing that we were describing earlier. Okay, and that's how you can describe motion using both words and confirming it graphically.